So today we are going to start chapter 6, which is all about square roots and exponents. So we're going to start lesson 6.1 day 1. So hopefully you were able to today in class figure out to memorize, well, not memorize, just be familiar with all the perfect squares. You don't have to memorize all of them, but it'll definitely help you out if you do have those memorized. So just keep practicing them and just keep recognizing them. Another cool thing about this unit is this unit will all be calculator unless I say otherwise. So most of this unit, I believe all of this unit will be calculator, but there may be one or two lessons where calculator is not allowed, and I'll let you know beforehand. But from here on out, for this unit only, calculator will be allowed for all of them. So today we are going to talk about simplifying square roots. So I can simplify square roots and evaluate them. Okay, so we're going to talk about first simplifying them and then how to evaluate them with variables. So why don't you guys quickly do this warm up, pause this video, and fill out these 4. It should come pretty quickly to you. First one should be 15, 7, 11, and 10. As I said earlier, you don't have to have these memorized, but it'll only help you if you do recognize these. It'll just help things go by a little quicker. Okay, so a couple things we have to learn first are the key ideas. So key ideas about square roots. So product property of square roots. So product means multiplication, so we'll be dealing with that. So all this is saying is, let's say I have the square root of xy, right? So that means I can split this up into square root of x multiplied by the square root of y. Okay, so how is this useful for me? Well, let's say I've the square root of let's do numbers 9 times 5, right? You won't be given 9 times 5 obviously, but you'll be given like square root of 45, right? You could split that up into 9 and 5. This I can then split up into square root of 9 multiplied by the square root of 5. Well, I know what the square root of 9 is, right? Square root of 9, this is equal to 3. Square root of 5, root 5 is prime, right? So I can't really simplify that square root, so I would leave that just as 3 root 5 to be simplified. Quotient property is pretty similar. Quotient means division. So in this problem, let's say I have the square root of x over y like this. All this is saying is I can split it apart. I could do the square root of x over the square root of y. So when we deal with numbers, let's say I have the square root of 3 over 4. This can be then split up into square root of 3 over square root of 4. One of these can be simplified. It's the bottom one, right? The top one, 3 is prime. I can't simplify that anymore. So square root of 3 over square root of 4 knows 2. So that would be simplified to root 3 over 2. So these are the 2 key ideas we'll deal with that you will use for the remainder of this unit. So make sure you know it's not too difficult, but it should help you out. So here's how you simplify square roots. Another way of writing square roots is radicals, right? So you'll hear that term interchangeably. It's 3 steps. Step 1 is to look for the greatest perfect square factor. So this is why it'll help you if you have these memorized, but you can use your calculator to help you out. Okay, so let's say you don't have these memorized, well then you can use guess and check for the calculator. If no perfect squares fit inside the integers, then they are already simplified. So let's say in a number no perfect square fits inside it, then that's as simple as it can get. So that's how you know you're done already. Okay, so after you find the greatest perfect square factor, you break the square roots into 2 parts. Okay, so you'll split them apart into using the properties of square roots. However, for the quotient property, you're just going to flip these steps. So steps 2 will come first, and then step 1, you'll see what I mean by that. Last but not least is just simplify. Forgot the S. And you are done. So let's do 3 examples together before I let you guys work on a little bit on your own. So square root of 150. Okay, so remember, perfect square roots. You're looking for perfect squares that would fit inside 150. So let's see. 25 comes to mind, right? Yeah, so let's split this up into square root of 25, right? 150, remember, you can use a calculator to divide by 25. I think of quarters. How many quarters would be $1.50? Will be 6. So 150 is equal to 25 times 6. So that's where I got these two numbers from. So this is according to the product property of square roots. I can always split them up into two radicals and have them still be the same value. So this is why having your perfect square sheet memorized is very helpful. If not, then you can use your calculator, be like, okay, 100 divided by 4, 100 divided by 9, 100 divided by 16, 100 divided by 25, and keep going until you hit the biggest perfect square that would fit inside your radical. Okay, so from here, I did steps 2. Right, step 1 was to identify 25 times 6. Step 2, we broke it apart. Step 3 is to simplify. Well, square root of 5 is just 5, or square root of 25 is 5. Root 6 can't be simplified, so I leave my answer as 5 root 6. Okay, next example. All right, so remember, for quotient property, I reverse it. So I break my square root into two parts first. So remember, according to the quotient property, this is the same thing as square root of 15 over the square root of 64. Let's see. Let's simplify, or let's look for the perfect square root of 15. Well, 4 does not fit inside, 9 doesn't, 16 is too big. So square root of 15 is already simplified. Why? Because as we said earlier, no perfect squares fit inside the integer, then it's already simplified. Well, I know the square root of 64 is 8, so that one was simple. Here is my answer in simplest form. All right, letter C, square root of 72. Okay, so now let's see. Perfect squares that fit inside 72. Well, let's go down the list. Well, 2, well, no, 2 is not a perfect square. 4, let's see, 72 divided by 4. I would use a calculator, but I don't have one. I get 18. Yes, 4 and 18 works. But let's see if we could get bigger, right? What about, what's next? 4, 9. 9 and 8. 9 is also perfect square. Let's see, 16. What, 72, 16. 16 times 2 is 32. 64. Nope, 16 does not work. 4, 5, 25. 25 does not fit in. What about 36? I get 36 and 2. Yeah, 36 and 2. 36 is a perfect square. So from here, you see we have 3 perfect squares that fit inside. I want to choose the biggest one. So the biggest one in this case is 36. So I could split this up into root 36 and root 2. From here, my square root of 36 is 6 root 2. So that is it in simplest form. Okay, so now let's say you didn't recognize that 36 fit inside, and let's say you went with just 4, right? So then, if you split it up into 4 and 18, what do you notice about this? Well, this is 2. Can my square root of 18 be simplified into more perfect squares? Yeah, this can be broken up into square root of 9, square root of 2, right? Square root of 9 is 3, so I have 2 times 3 times root 2, so I get 6 root 2. I get the same exact thing, but less work if you choose the bigger one. As I said, since you are able to use a calculator, I would just keep going until you are not able to divide and fit inside these integers. So I get 6 root 2 to be my simplest form. So why don't you guys try the on your own problems. All right. So for this one, real quick, root 23 over root 9. I get root 23 over 3. This one, perfect squares, 4, 9, 16. I think 16 fits inside, right? 16 and 5. I think. Yeah, 16 and 5. So I have square root of 16, square root of 5. I have negative 4 root 5. Why? Because the negative, don't forget about that as well. All right, this one, square root of 27 over square root of 100. Well, the bottom one is easy. That's just 10. right? The top one, let's say 27 splits up into root 9, root 3, so I get 3, root 3 up on top. Why? Because this becomes a 3, right? And you leave it just like that. Okay, so if you were confused, go back, rewatch this part. You could pause it as well if I'm going too quickly, so feel free to work on that. All right, next part, evaluating square roots. You cannot forget about order of operations. Okay, so what do I mean by that? So anytime we input numbers, we plug in numbers, you have to always put them in parentheses. So what does that mean? Well, let's plug it in. So I have -8 is b, so I have -8 parentheses squared. Notice how I put the negative inside the parentheses as well. Do not forget that. -4 parentheses 2 parentheses 4, square root of all this. All right, now let's simplify the inside. -8 squared is 64. Minus, if I were to do that, I get 32. 4 times 2 is 8 times 4 is 32. Don't forget the square root symbol. Okay, now I have to figure out the square root of 32. Perfect square is 16 and 2. Right? Let me finish this. Square root of 16 is 4. Square root of 2 is just square root of 2. And here is my simplified answer. Okay? Alright, now why don't you guys work on this last problem on your own, submit your answer, and that is it for today's lesson.